here. So what is our objective here in this problem? We have to calculate a general solution for this Gauss hypergeometric equation about the point x is equal to 1. Previously, we have calculated for the regular singular point for x is equal to 0. The general solution we have got in the terms of hypergeometric series. Now, to get the solution for this one, let us consider x minus 1 is equal to t. Okay, so therefore we can have dt by dx will be 1. Now, what we are doing is we are converting our whole equation. See, why we are taking x minus 1 equal to 0? Because x minus 1 is the regular singular point. So what we are doing, we difference or we convert we are shifting our coordinates at x is equal to 0. So we will convert all this differential equation in terms of t. And so whatever the new equation we got, in that equation, the regular singular point will be t equal to 0. So what we are doing, we are shifting our coordinates at the point x is equal to 1. So so whatever the new equation will construct, that will have the regular singular point at 0, and for that we will proceed for the next. So that's why what will be the dy by dx. So as per the chain rule, this is dy by dt into dt by dx, but dt by dx is 1 due to this. So that's why it is dy by dt. So what is d square y by dt dx square? Again by applying the chain rule. The d square y by dx square can be written as d by dx of dy by dx, but dy by dx is dy by dt. And here we apply the chain rule, that is d by dt into dy by dt into dt by dx, but dt by dx is 1, and so this will be nothing but the d square y by dt square. So ultimately what we get is d square y by dx square is this. So now we can able to convert this whole equation into terms of t. So whenever x is there, we have to substitute t plus x. So this will be gives you t plus 1, because instead of x we have to write down t plus 1, and 1 minus x will be minus t. So this is minus t. What we have observed, y double dash is actually d square y by dt square. So that we can write down d square y by dt square plus what we have, it is c minus a plus b plus 1 into x, that is nothing but the t plus 1. Okay, into dy by dt, that is y dash minus aby. Now this expression can be rewrite at is this form, minus of t into t plus 1 d square y by dt square plus c minus a plus b plus 1, because this a plus b plus 1 will multiply to t and multiply to 1. So that's why it is this minus a plus b plus 1 t dy by dt minus aby equal to 0. So this is the things we got. Now further to this one, I just change another variable, that is let t equal to minus u. To doing this, what is du by dt? We'll have it as minus 1. So what is dy by dt? That is dy by du into du by dt. But du by dt is 1, so that's why, sorry, it is -1, so this is minus of dy by du. And d square y by dt square, by the same argument as we have did previously, this is nothing but the minus of d by dt of minus dy by du. Again, by you use the chain rule, then this will be d square y by du square into du by d. Minus is there, but into du by dt is there, but du by dt is -1, so that minus minus become plus, so it will become plus. Have you understood this? If not, then I will do the calculation.
No, sir.
Okay, see, d square y by dt square is there, so that is d by dt of dy by du. dt is first, but dy by dt, in the previous slide, dy by dt is minus of dy by du, that is d by dt of minus of dy by du. But again, by applying the chain rule, dy by du is dy by du, and that minus sign I can take out, and that into du by dt by applying chain rule. Now du by dt is 1, sorry, -1, so that minus minus become +1, and this is nothing but the d square y by du square. So d square y by dt square is d square y by du square we have. Okay. Now substituting these values into this equation. So instead of t, we have minus u. So that's why this is u. This will be minus u. So that's why it is 1 minus u. And d square y by dt square is d square y by du square. So that's why it is d square y by du square plus the whole thing is as it is. Just instead of this t, there is a minus u is there. Okay. So that will gives you a plus b minus c plus 1. So that is a plus b minus c plus 1 plus a plus 1 plus u, because here it is minus sign. Due to this u, it will become plus, and dy by dt is minus of du by, so this plus will become minus, so that minus of dy by du is there, minus aby is already there. Now this I can rewrite into this form. This will be what? Because let me, yeah, I will write down this is into next page. That will be better, because so we'll have u into 1 minus u d square y by du square plus, you just write down the form of the hypergeometric equation, that is this x square, so x into 1 minus x d square y by dx square plus inside bracket a plus b plus, sorry, it is c minus a plus b plus 1 into x dy by dx plus, sorry, minus aby equal to 0. So this is the equation we have. Now into this equation, now if you compare with this, I want to write down our equation into that form. And this minus sign will affect, this will be minus, this will be minus, this will become plus, and this will become minus. So that's why we have it as minus a minus b plus c minus 1 minus a plus b plus c plus 1 into u into dy by du minus aby equal to 0. So if you compare now this differential equation with this one, we already have the solution for this hypergeometric series. The solution for this hypergeometric series will be y equal to c1 y1 plus c2 y2. What was this solution for this differential equation? That is f of abc x plus c2 x power 1 minus c f of a minus b plus 1 है ना, એવું જ હતું ને. That was we have a minus c plus 1 b minus c plus 1 2 minus cx. A minus c plus 1 b minus c plus 1 then two minus c x. This is the solution for this equation that we have, that we know from the previous result. So now what will be the solution for this equation we can write down. So you have to compare. So here instead of a we have a, instead of b we have b, only the place of c is changed. So in the c place of c we have this quantity. बराबर ना? So the solution for this equation, that is y, or I can say, yeah, y in terms of u, that is c1 f of ab is as it is. Instead of a we have a, b have b, but instead of c we have this quantity, that is minus a minus b plus c minus 1 u. Instead of x we have u here plus c2 x raised to 1 minus c, so it is u raised to 1 minus c into f of, instead of a we have a, now instead of c we have whole this quantity, that is minus a minus b plus c minus 1. Then instead of this quantity we have b minus a minus b plus c plus 1. Here is also plus 1. Minus c plus 1 is there. Okay, here is also minus c plus 1. Then 2 minus c, that is 2 minus a minus b plus minus c, that's, this will be plus plus, this is minus plus 1, and u. And again you substitute the value of u. What is the value of u we have? The value of u we have assumed as minus t. But what is minus t? Minus t is nothing but the x minus t. So the minus t will be 1 minus x. So instead of u we can substitute that 1 minus x here. So here if you substitute, instead of u is 1 minus x, here it is 1 minus x, here it is 1 minus x, then that will be the solution of the given, that is this differential equation for the regular point x is equal to 1. That is for the solution for the hypergeometric series for equation or for regular singular point for x is equal to 1.